Hi guys, Mrs. Hedrick here. Hey, today we're working in the instruction book on page 178 and 179. This is Math 8, April 23, Lesson 20, instruction book 178, 179. You need a pencil, and if you have a calculator would be lovely. Okay? All right, my friends, so we've been talking about this lesson. Lesson 20 is about transformations that change the size, right? We did translate, rotate, reflect. The shape stayed exactly the same size. But when we added dilations, we could take the shape and make it, we could spread it out, make it get bigger, or we could shrink it down and make it get smaller. Okay, so let's take a look at this one. Today they're going to combine those. We're going to combine a dilation with another transformation. Okay, hang on. My dog is knocking at my door. Okay, sorry. I'm up in my craft room now, office teaching room, and my dog was outside the door. Now she wants in. Okay. All right, my friends, let's do this. Read the problem below, then learn about combining a dilation with another transformation. Okay, let's take a peek at our picture here. In the diagram below, excuse me, triangle PQR, the little red triangle, is similar to triangle LMN. So they're already telling me that they're similar. So I don't need to check. I know that they are. So that means that there was a dilation involved here. Describe the sequence of transformations that transforms triangle PQR, the red one, to triangle LMN, the new one. Okay, so let's go through our book. First thing they said is model it. You can describe the transformations in words. Okay, it took me a minute to see this. Obviously, they made this bigger, right? They dilated it, made it larger. So that means it has to have a scale factor of greater than 1. And then I guess this points away, and then it points away over here. So they did the pancake thing, right? Spatula underneath, flip it over. So this is a reflection. And they went ahead and told me that. Triangle PQR was flipped or reflected over the y-axis. I can see that now, right? Put the spatula under here, flip it over. We flipped it over the y-axis. And then it says PQR was increased in size or dilated about the center O, the origin. So something to keep in mind. So they're saying that that's the center of dilation. So remember from yesterday, the coordinates for the origin are 0, 0. The coordinates for the origin are 0, 0 on both of those. Hopefully that makes sense to you. None of these are shared points. So they dilated about the center. So that means that in both of these pictures, what are the points on O? Yeah, 0, 0. Oh, look at this picture. What are the coordinates for O? 0, 0. So they didn't change. Okay, now here's the tricky part. The scale factor is 3/2, 3/2. So I want you to write yourself a note. So when we do scale factor, okay, yesterday I had them backwards. Okay, so we're going to put scale factor is going to be the new shape over the original. Okay, so that's important. You could highlight that. I didn't tell you the highlighter, but that's important. Write that out. If you need that when you take your quiz, you'll have it. Okay, so new shape over original. So let's go to our new shape. This is the blue one. Can I count the length of any of these sides? It's kind of hard, isn't it? Because they're all kind of twisted. If you look, one set of the sides cuts diagonally across the squares perfectly. And if you look, it's this one and this one. Now, if you look at these, look, they cut like they don't really keep a good pattern, but these two cut exactly diagonal. All right, so if you count them, count the blue one. I know we're counting diagonals, but we're going to do it anyways. 1, 2, 3. So if I come down here, new shape on top, 3 over. Now you have to find the corresponding side, right? I can't go over here now and compare it to a different side. These two correspond. Now count this one. 1, 2. So that's a ratio, isn't it? New shape to old shape. So that's a scale factor of 3/2. New shape has 3, old shape has 2. Okay, let's keep going. Now, we're going to do each one of these. These are corresponding, right? P, Q, and R. P, Q, and R match L, M, and N. Okay. Now, here's an interesting thing. I'm going to move these out. You know how I like to write and have more space. So, P is -2, 0. Q is -4, 4. And R is 0, 2. These are the original. I'm going to transform them by a scale factor of 3/2. So just like we did yesterday, we're going to multiply each number by 3/2. And then we're going to get the corresponding number, corresponding vertice. Sorry, I'll get it out. Okay, now I have my calculator that does fractions. So I can type in 2/3. Excuse me, 3/2, but you probably don't. So off to the side, let's think about it. 3/2 is 3 divided by 2. What's 3 divided by 2? 2 goes into 3 one time. So that's a 1.5. So on your calculator, if you do 3 divided by 2, you get 1.5. Actually, look at me. I wrote it like let's write it as a decimal. So for you guys at home, you can multiply by 1.5. 1.5, 1.5, 1.5. Okay, let's do it. This is going to work. You ready? We're going to multiply each one of these coordinates by 1.5, or 3 over 2. So the first one is -2. -2 times 1.5. I get -3. What is 0 times 1.5? 0. 0 times anything is 0. Okay, let's go down here. What's -4 times 1.5? -6. What's 4 times 1.5? That's going to be 6. Okay, what's 0 times 1.5? 0. What's 2 times 1.5? That should be 3, right? Okay. Now, I want to go back up. Now, look, these don't match exactly. Do you see a difference here? Can you see what happened? These are the numbers after they reflected it. Let's do a little trick here. Let's, I don't even know what to call these. I should probably not call them L, M, and N. I should probably call them like P prime, Q prime, R prime, because I haven't flipped it yet. All right, let's go up and graph these on here. Okay, let's do it. So my P prime, my new P is going to be -3, 0. So -3, 1, 2, 3, 0. So that's going to be like my P prime. Okay, my Q is -6, +6. So let's go out -6. 1, 2, 3, 4, 5. Well, I pretend. -6, +6. 1, 2, 3, 4, 5, 6. So it's out here. That's okay. Life goes on. Right? We're doing our best. All right, and then R prime, my new R is 0, 3. I'm plotting these points that I got by multiplying the original by 3/2. Okay, R prime is 0, 3. 0, 1, 2, 3. Ooh, that one touches. Okay, now if I take a ruler, where am I hiding my ruler? Oh, come on, man. Oh, there it is. I found it. It was under my calculator. Okay. If I take my ruler, you know what? I feel like I want to do it in red. Do I have a red pen? I don't have a... Oh, I do have a red pen. Ding, ding, ding. Okay. What I did was I made this triangle bigger first. I dilated it. Can you see how I dilated it? So I took the original triangle, PQR, and I dilated it by a scale factor of 3/2. So I multiplied each number by 3/2, or 1.5. And this is my new triangle. Now, okay, try to ignore the little guy. Look, can you see it? It's a perfect reflection right across the y-axis. So if I take this new triangle, put a spatula under it, flip it over, that's where it lands. Now, let's go down and see what happened to these numbers. So once I reflect it, this turns into L, which is 3, 0. That changed its sign. That went to a positive, not a negative, right? This became positive. And Q prime becomes M, which is 6, 6. Look at what changed. That stayed the same. But what's happening, the x coordinates are flipping their sign. And R prime becomes N, which is 0, 3. So can you change the sign on a 0? You can't, can you? A 0 stays a 0. So once I flip, and if you go back up and look, once I flip, these go from -3 to a +3 and a -6 to a +6. Does that make sense? And see how this one doesn't change? That's a shared point. Aha. All right, we did it. So they flipped and dilated. We dilated and flipped. We just did it backwards, but it works. Okay, so let's go to the next page. What line of reflection is used to transform PQR to LMN? What did they flip it over? They flipped it over the y-axis. Okay, let's go back and write y-axis. What's the line of reflection? It is the y-axis. Okay. And how do I know that? Well, one of the tricks I know is that the x coordinates change their sign. In our case, they went from negative to positives. Okay, let's go to the next one. What scale factor and center are used for the transformation of the reflection of triangle PQR to LMN? Okay, well, they told us the scale factor, right? They already told me that. I'm just kind of copying that. The scale factor was 3/2. And they kind of told us, too, that I can't spell, the center was 0. Okay. Number 4. Does it matter if triangle PQR is first dilated, then reflected? Or does it have to first be reflected, then dilated? Ha! We did it. We did it. We did it backwards. We dilated, then flipped. They're saying in their book that they flipped and then dilated. Would it matter? Doesn't matter. No, it does not matter. You still get the same shape, right? You still get the same, hang on. You still get the same final shape. Okay. Suppose triangle LMN was the original figure, and PQR was the image of the sequence of transformations. Would this change the description of the transformations? Okay, so they want to go backwards. So go back to your picture. They want to go from here back to here. Big shape to little shape. Okay, so I know in a dilation, if it goes from a larger to a smaller shape, the dilation has to be less than 1. Right? Okay, I also know that the new shape is on top and the original is on the bottom. Okay, what if I flip those? So they said they want this to be the original and this to be the new shape. So I'm going to go from a 3/2, I'm going to flip them, right, to a 2/3, which makes sense. How would this change? So my scale factor would be flipped upside down. It would become 2/3. And 2/3 is less than 1. So that means this shape is getting smaller, okay? And then would I still be reflecting across the y-axis? Let's go back and look. If I take my spatula now, put it under the blue shape, and flip it over, am I still reflecting over the y-axis? Yeah, that part hasn't changed. So the scale factor becomes 2/3, and we are still reflecting over the y-axis. Okay. Does it change the description of the transformations? No, not really. It's still a dilation, except this time it's getting smaller, and we're still reflecting over the y-axis. Okay. In problem 5, this one, shows that the dilation with a scale factor between 0 and 1 shrinks the polygon. That is between 0 and 1, and it would get smaller. What do you think the effect of a dilation is with a scale factor of 1? Okay, let's try it. Let's go back to our original coordinates. All right, so let's say one of my points was P was -2, 0. What if my scale factor is 1? What does that do to those numbers? Well, -2 times 1 is -2, and 0 times 1 is still 0. So my new P, my P prime would be, look, it's the same shape. So if you multiply by a scale factor of 1, the shape stays the same. So we're going to say scale factor of 1 equals same shape. No change in size. No change in size. Okay. All right, so far so good. All right, let's try. Let's do our try it here. All right. Let's see. This is shape UVWO. UVWO. It's a rectangle. Dink. Is similar to DEFO. DEFO. This rectangle is similar to that rectangle. That means they already have a scale factor. When they tell you this similar, that means they already figured it out. Scale factor, so there's a dilation involved. Describe the transformation or sequence of transformations to turn UVWO to DEFO. Okay. First of all, it's getting smaller. Do you agree? The big one to the little one. So I'm going to write myself a note. It's getting smaller. So that means my scale factor is going to be less than 1. So it's going to be a fraction, right? All right, look at this. Long side here, long side here. How do you think they got this thing around the corner? It doesn't look like a reflection, right? If I reflected this, if I put a spatula under the big guy and flip him, then that means the long side should go this way. It's not a translation. I can't slide this over here. Again, long side. So that must be a rotation. So there's a rotation. I know that. Okay, let's see if we can figure out the scale factor first. I'm going back to my notes. So the scale factor, I'm going to put SF. The scale factor is the new shape over the original. Or I could put new over old, couldn't I? All right, let's see if we can figure out our scale factor. Let's do the long side, right? Or you want to do, no, let's do the short side, because then I won't have to reduce it. Find the short side on both of these. The short side here is 1, 2, 3. The short side here is 1. All right, what is the new shape? The new shape is this guy. So my scale factor is new shape 1 over corresponding side original shape is 3. So I have a scale factor of 1/3. So this is 1/3 of the size of that. Okay, I did that. Scale factor less than 1, check. And if I rotate this, do you think that would get it to this spot? I think it would, right? It would shrink it down to here. And then we would rotate it around this point, right? I would push this around. I would turn it. I'd actually rotate it 90 degrees, right? Oh, that's a rotation. 90 degrees this way. What is that? Clockwise or counterclockwise? Okay. All right, my friends. Okay, you have some practice work to do. Get into your homework book. Do practice and problem solving. We're going to do page 213 to 214. I know you don't want to do it, but it's good practice. I already posted the answer key, so you can go back and look at the answers. If you get stuck, you can go look at the answers and try to figure out what happened. Don't copy. That's a waste of everyone's time. Okay. All right, my friends. Good luck, and I will see you tomorrow.